let's start with a big question. What if the very foundation of modern physics is broken? Today, we're diving into that exact idea and a pretty radical new proposal for how we might fix it.
You know, for the longest time, we've treated things like dark matter and quantum entanglement as these separate, isolated puzzles to be solved. But what if they're not? What if they're actually just symptoms of a much more fundamental flaw in the way we see the entire universe? That's the core question we're going to explore.
So yeah, let's start right there with these mysteries. We're talking about the biggest, most stubborn problems that have had physicists scratching their heads for decades, even generations.
I mean, we've built these incredible theories, right? General relativity, the standard model, but they've kind of led us to an impasse. We find ourselves searching for particles we can't seem to find and trying to make sense of ideas that just break our brains. This isn't just about filling in a few blank spots. It really suggests that maybe the entire picture we've been painting is wrong.
So where is this supposed crack? Well, the theory we're looking at today argues it's hiding in plain sight, right inside the most successful theory of gravity we've ever had, Einstein's general relativity.
At its very heart, general relativity is built on a really specific idea. It slices up reality into two separate interacting pieces. You've got energy on one side, and you've got space-time on the other.
A really great way to think about this is like a play. General relativity says reality has two parts. You've got the stage, which is space-time, and then you have the actors, which is all the energy and matter. The actors' movements actually bend and warp the stage, and the shape of that stage, in turn, tells the actors how to move. Two separate things locked in this constant cosmic dance. But here's the absolute kicker. This separation, this idea of two things, was never a proven fact. It was a philosophical choice that got baked right into the mathematics, an assumption that has been guiding physics for over a century, and honestly, it's gone largely unquestioned. So, what if we just toss that assumption out? What if reality isn't two things, but just one? This leads us to a pretty revolutionary idea, a single, unified fabric of reality. And this gets us to the core idea of this new model. It proposes there is no division at all, not one. There's just one dynamic, elastic fabric. Everything we see, from stars to you and me, isn't just on the fabric, it's a feature of the fabric itself. The real power of this idea boils down to one simple word: elasticity. See, Einstein's spacetime can be warped, like a bowling ball on a trampoline. But this new fabric, it's inherently elastic. It can ripple and vibrate and resonate all by itself. It's not just the stage anymore. It is the entire performance.
And the implications here are just profound. The stage and the actors are one and the same. What we call energy is really just the shape, the geometry of the fabric. And particles like us, we're just these incredibly complex patterns, resonances, and wrinkles within this single, unbroken whole.
Okay, I get it. This is a beautiful concept, but does it actually work? The real test of any theory, after all, is its power to explain things. So let's see how this one fabric model handles those huge mysteries we started with.
First up, the big one. We have spent decades and literally billions of dollars hunting for some mysterious dark matter particle that's supposed to be holding galaxies together, and we have found absolutely nothing. So what is it?
Well, according to this new model, we've been looking in completely the wrong place. Dark matter isn't a particle. It's not an actor. It's a property of the stage. It's a huge, slow-moving wave that's rippling through the elastic fabric of reality. Its geometric effect is what we've been mistaking for the gravity of a missing particle this whole time.
And this leads to a very bold, very testable prediction. If this model is correct, our search for a dark matter particle will always come up empty because it simply doesn't exist.
All right, let's pivot to the other great mystery, the one that famously bothered Einstein himself, quantum entanglement, or as he called it, spooky action at a distance. How in the world can two particles influence each other instantly across the entire universe? The old answer just kind of accepts that reality is weirdly non-local, but the fabric model offers a much more intuitive explanation. The spookiness totally disappears if you realize the two particles were never really separate objects in the first place. They're just interconnected patterns within one single undivided fabric. Measuring one is just revealing a property of the entire pattern.
And the explanatory power just keeps going. In this view, gravity isn't a force carried by some particle, it's just the overall shape of reality. The other forces?
They're just tiny wrinkles in that fabric. And this means the hypothetical graviton, the particle we think carries the force of gravity, is also completely unnecessary. It doesn't need to exist.
Now, I know what a lot of you are probably thinking. This is a fascinating concept, but where are the equations? Where's the math to back all of this up?
And that's a fair question, right? It's a really common objection to new conceptual models. Physicists will often argue that without a full mathematical breakdown, it's not really physics, it's just philosophy. But this model proposes a different path forward. The argument here is that you have to start with a coherent, believable concept first. Then you can build a simulation, compare that simulation to reality, and finally develop the mathematics to describe what you're seeing. In other words, the math should serve the concept, not the other way around.
So, the next step isn't some single elegant equation. It's something much more modern, a numerical simulation. We can actually model this fabric as a network of points on a computer, and then run experiments, smash two virtual particles together, and see if its behavior matches what we see in the real world. It's a completely rigorous, scientific process, all guided by that core concept.
And this all brings us to our final thought. This theory does way more than just solve physics problems. It really changes our definition of what we are. It asks us to consider this massive shift in perspective that maybe we aren't separate things just living in a universe. Maybe we are the universe, experiencing itself as these temporary, complex ripples in one grand cosmic fabric. Something to think about.